Okay, so I'm making a horn bell. Actually, another horn bell. So this is kind of a bunch of stuff video, but we got some cool shit going on, boys. Remember how I used to draw bells with steel? Actually, let me grab one because that's a good example. Okay. Oh, they're sticky. Ugh. So these are from trumpet bells, obviously. This is an example of one that drew really well. You can see it's not torn. It's just torn a little bit, but at the very end, this drew really good, which is kind of the goal. This one drew very poorly, so it pulled up a line that had to be burnished and spun out. And you can get the results good after that, but it's never perfect. I no longer draw with steel. If anyone needs like 100 6x6 steel washers with a 560 hole through them, let me know. I just don't need them anymore, don't want them. Then I'm drawing with a new material. It's super awesome. It's reusable. This is a horn bell that's been drawn. And for a long time, I've been thinking about switching over to lead. And lead has a lot of positives, but it has what I believe is an overwhelming amount of negatives. So here's a lead blank. The trick is with lead, and this is something I had to learn, I got my hands on a lot of lead. Like a lot of lead. Came out of the ground. I was so excited. I had several 100 pounds of lead. I was going to do lead washers for all my horn bells. It was going to be great. And then I started using them, and the results were not great. I have pictures of them somewhere. I'll send to Colin. But it starts fracturing. And it's because the lead that I have was heavily alloyed with tin is one that makes it hard, and the other one is arsenic? Something with an A. Colin will look it up. But this one here, I actually never tried, but this is pure lead. I bought this on the internet for like people who reload ammo use pure lead, and that's what I bought. I never tried it because I found this stuff and it's great. The one issue with lead is the tightness of the draw. It's not very tight. Steel is pretty tight for all of its issues and the draw lines and everything it pulls up. This material right here is the bee's knees. So this draws so far up the flare. So with steel, because a horn has such a rapid change in diameter from the bore to the throat, my steel bell washers would only draw up to about here. So only about 30 inches, leaving over a foot that has to be spun. Probably about 16 inches that has to be spun like there down. And what that does is that means you're never gonna get the bell tight to the mandrel if you're spinning that far off. It stems from a lot of people have different definitions of what's tight to a mandrel. When you draw a bell down and take it off the mandrel, when you draw a bell down to a mandrel, it's tight. You take a piece of steel and you tap, tap, tap on the bell and you can hear the mandrel under it. You take that bell off, you put it back on, and it ends up being loose up here. There's ways to mitigate that with heat and stuff like that, which I do, but most people don't. Most people have it loose up here, and then they spin down, and what that does is that causes this part here to push back towards the end of the mandrel. I actually did this on accident once when I forgot to put a bolt in, which is a kind of accelerated version of what I'm talking about now. If a bell pushes back, loosening up the entire tail section, it actually lengthens the bell, so the bell is no longer in the proper shape of the mandrel. So the flare might be tight right about here, but it's loose all through here. And you can gain about an inch doing that, believe it or not. Even more so, what that does is if you're bolted rigid, which means like the nose folds over and you're bolting that nose to the face of this mandrel, if there's any soft spots or weak points in the tail back here, spinning on a hollow bell will actually crinkle the bell. So the bell will just kind of veil itself, which ruins it, and you really can't fix it. And you shouldn't fix it even if you can. These new washers, you can see it's going over there, but that's because there's so much pressure that these actually shrink about a 1/4 inch after drawing. I have pictures of how far this is drawing up, and I can get it to about there without tearing this. I can go further, but they tear. I might find that it's worth it just to have them go further, but for now, reusable is a pretty sweet option. They're also cheaper and way more cost effective than steel. The last thing is the draw that comes off of using these washers is insanely tight to the point where I have to heat the bell to get it off the mandrel a lot of times. But anyways, what I want to talk about is garlands and my annoying experience with garlands. So one, let's get it out of the way. I do not think garlands play well. I think they play poorly, just generally. And you can argue with me, but I don't, one, really care that much how they play. And I don't, two, really care about arguing with people who say they play good. I just think that they sound dead and they add way too much weight to a horn. But people like them, and that's great. This is a garland blank. It's actually an old one. I spun a bunch of these a long time ago, and I didn't do a really good job trimming, so they're kind of jagged. So I've been practicing with these. I've spun successfully garlands down actually a lot. There's one I did on that bell. That one turned out really nice. It has not been a good process for me in the past. It's been kind of like, sometimes it works, sometimes it doesn't. And I reached out to a couple friends who have experience, or at least more experience than I do, and they were very helpful in kind of explaining that I'm doing it the wrong way. Well, I'm doing it in a way that can be done, but probably shouldn't be done this way. It doesn't need to be done this way. So in the past, what I did was I took the garland, put a wire in it, obviously. I actually silver soldered the two ends of the wire together so that they'll never rattle if it gets loose for some reason. I put it on the bell and then spin the lip over on the garland. The garlands have a lip that clenches it over the back side of the bell. You can also hammer them over and get good results. It's just not very consistent, and I'm not very patient. I'll show you all the spinning process and all that later. And then what I was under the understanding that everyone did, I then took the bell with the garland installed, put it on the bell mandrel, and then I spun the garland down to the bell. And in brass, that works fine. No issues in brass. In nickel silver, it is a royal pain in the fucking ass. Like, what happens is when you're spinning the garland down and you get to the end of the garland right here, it work hardens so much, so quickly that it just, the end lips up and there's a gap all the way around the garland. The way I've gotten around this in the past is two ways. The way that makes me stay up at night thinking about the terrible things I've done that somehow worked out is you take the entire bell with a small torch and you anneal the garland that's sitting on the bell, and then you respin it a couple times to get it to lay flat. And that does work, but that is not a great process. The other way that I've got it to sit down is cut the garland long for what you want it before you spin it down, and then you spin it down, and then you take a trimming tool and you really carefully trim the garland where it's sitting down in the mandrel. And that does work, but it's also a little scary. So I don't want to do that way anymore. Apparently, the way that everyone does it, and you can only do this if your garland off your mandrel is a close fit to your bell, which mine is, which is good, on the Ullman. The trumpet one is not. I gotta redo that one. What you do is only anneal the edge of the garland where you're gonna spin the lip over. Don't anneal the face. Spin the lip over. That will suck the garland in tight to the bell, and that's it. You don't spin the face down. It's just not necessary. And I now understand this, and this now makes a lot of sense. Now I kind of feel silly for trying to spin garlands down to the face of the mandrel. It just seemed like the right way to do it, but that's okay. I believe what I'm gonna do here is, there's the mandrel I gotta get out. I'm gonna spin on a new garland, and I believe the best way to make this garland come out as good as possible, because I do solder my garlands. They get soldered here, down to the bell, and then they get soldered here. But there's kind of a process that goes with that, at least for me. Since we don't have to spin the garland down to the bell, the garland can have a bright polish, or at least a sanded finish up to where we have to sand to, going into the assembly. And that means that, like, this is ready to buff right here, and that's where the garland sits. There's no sense in polishing under the garland. We're gonna leave as much material on there as possible, just to give it extra strength. This area likes to get dented a lot because of the garland being there. When dents do happen here, they tend to be exacerbated by the garland sitting there. So we're gonna leave as much material there as possible, sand it up here, ready to buff. And what we are gonna do is we're gonna do the same with one of the garlands. I'm gonna make a new one and sand it up to ready to buff. And then we'll drop it on, put the wire in, spin the lip over, and then you flip the bell around and you have a bell that is ready to go on this side. And then I just polish out the inside, and then we are off to the races. This thing is ready to bend. I like that a lot, so we'll get that going. I guess you could do the inside too, but I don't think there's any sense. I will do the around the rim. Why is there a line there? I think I need to put that back on and spin that down a little. I will take a little Scotch-Brite wheel on a Dremel and polish around that rim a little bit before I fold the crease over. Let me fix this little thing I'm seeing, then I'll bring it back when we're making the garland. Well, I completely forgot to take a video of that, but I just drew this bell, and it's so good. So you think you see lines, it's just the oxidation from me burnishing with the brass on it. You can still see the spinning lines, but they have no texture. So that means we're not overly stretching the metal at all, because with steel, when you draw it and you have spinning lines, the spinning lines go away. Big takeaway from this is the washer after being drawn. This one has been drawn, you can see the two lines, it's been drawn twice so far, reused, and it's in pretty good shape, no cracking, no nothing. And the draw line is all the way down there, and you can actually see, it gives you an idea for how tight these draws are. The washer is already sprung back about 2 inches from where it was. And we have a bell that is tight to the mandrel here, which is really good. That's going to spin out really well. Really an improvement. So yeah, this will get boiled and reused. So this is ready to go back on the lathe. I actually got to pull the bell off of it. But that's a huge improvement, because before, like I said earlier, I was only drawing to about here. What that does is so that you have to spin the rest of it down on the mandrel, and this is right where the bend is. So that will cause, if there's any weird spinning lines left in your bell when you go to bend it, it'll cause that to fail, or like pull up a crease or a ripple right on where that spinning line is, where it has a weird spot. But this, it's almost all the way to where the ring sits. The ring would sit right about there. I could draw further, but it destroys the washer, and I like the idea of reusing them, at least for now, Trumpet bells, they'll reuse them, no problem. Horn bells, I'm still on the fence. For now, we're good.